Hello. Hi, everyone. I'm Jota Carpanelli from OpenZeppelin, work as head of security for the team. And today I'm here with you to talk about security considerations when building Uniswap V4 hooks, or at least basic security considerations, because many things can happen when you are implementing hooks. Short agenda for today, because we only have 10 minutes. We're going to talk a little bit about Uniswap V4, what hooks are, and we're going to go through 4 main, but also very simple security considerations to take into account. And we're going to see some code snippets and some examples in real code, or at least ChatGPT-generated code that I used to create these slides. And then I'm just going to list a couple of other considerations, but again, the list is literally infinite, so let's get started. So to start, what Uniswap V4 is, I'm going to assume that most of them know Uniswap V3, Uniswap V2, know kind of like how the protocol works. But basically, in Uniswap V4, we have a main contract, a singleton, that is a pool manager. The pool manager, differently to Uniswap V3, has all the operation logic. So basically in V3, if you wanted to have a contract, a pool, you had to deploy it. So you would have as many contracts as pools you had. In this case, this is not like that. All the pools live in the pool manager, and the pool manager defines all the different functions that we already know from Uniswap, like swap, add liquidity, remove liquidity, mint, burn, etc. In this example, I also said some sort of like a pool operator contract that in Uniswap V4 at the moment could be the Uniswap router, could be also the position manager, but actually can be any contract that you want to build and talk to the pool manager, you just can do it. The flow works as follows. The user first calls this random contract or router. Let's just take the example of the Uniswap router. What happens here, since these contracts implement transient storage, and given that we have transient storage, we can preserve state throughout a transaction from the beginning to the end. We first will call an unlock function. The moment we call the unlock function, we can basically do whatever we want in the pool manager and interact as much as we want with as many pools as we want. So basically, if you want to perform a flash loan taking all the USDT from all the pools that exist in the pool manager, you should be able to do it. This then triggers an unlock callback function that goes back to the router, for example, and then the router takes care of calling the following function that can be, for example, add liquidity or a swap. So that's what I call here operation. And again, this operation could be many operations, could be anything. And finally, when everything is finished, the same unlock function will call the lock function so that no one after this specific operation or set of operations can be run. What is a hook? A hook is a smart contract. This smart contract has defined in its interface many functions. A hook is basically, as we said, or as we saw in ERC20s back in the day when we had the before transfer function, so basically, or after transfer function. It's basically code that you can run before and after an operation. In this case, we don't have transfer because it's not a token. We have swap, initialize, add liquidity, remove liquidity. So we have functions like before swap, after swap, before initialize, after initialize, all the ones that you can see here. These hooks, you set them at initialization of a pool, and it's going to be the same. Could not be the same, but ideally it's gonna be the same for a specific pool throughout the life of that pool, and implements logic. All these functions you can implement basically whatever you want, and we're going to see a little bit of that now. So what can hooks do? In this list, I give a couple of examples. A hook can be an oracle, can basically say a price of a specific token of a specific pool. Can be another router or another position manager. Could be Uniswap V2. We can set, for example, We can kill the range implementation of V3 and V4 and just have swaps on the whole range of a pool. We can implement lending borrowing. Let's say that we want to mint a U token that represents the position of liquidity of a user. We can give rewards. We can give access control to a function. For example, not everyone should swap this specific token, so kind of like a block list or allow list if we wanted to. Basically, you can do anything. Since you can code whatever you want, you can implement whatever you want. That's why I'm kind of like here talking about this, because I think this is going to be very interesting next year. A lot of protocols will be building on Uniswap V4 hooks and implementing their protocols there. So since it can do anything, also means that we can have out-of-date oracles. We can take positions of users. We can block list a specific list of addresses. We can introduce bugs. We can take tokens from users. We can basically introduce any bug, and that's why we have to talk about security considerations. To start, multiple pool management. So here we have an example of, actually it's not an example, it's a simplified version of the initialize function in the pool manager that Uniswap V4 implements. It has 3 main parts. The first one is checking whether you're passing a hook contract. Then it calls this aforementioned before initialize hook, and then it creates the pool, and finally executes the after initialize hook. So as I said before, these hooks are like contracts that anyone can implement, anyone can deploy, and as we saw in this example, what we're sending here in that pool key parameter initializer has information of this hook, but again, this function can also be called by anyone, so anyone can initialize a pool, and therefore anyone can set for a specific pool any hook. So something we had to take into account is that a specific pool can have, a hook can interact with many pools. So one thing to take into account in this example of this hook, we have the before initialize function, and we're setting the pool info, which is basically just an address, as an ERC 721. Let's say that in this before initialize, what we want to do is just deploy an ERC 721 that we're going to use later for liquidity providers to mint them an NFT, let's say a cat or something like that. So as I said, since a hook can be part of many pools, it's very important for us to do proper pool management. We cannot expect that multiple pools are not gonna interact with a hook. So every time we play with the storage of a hook, we have to be sure that another pool is not gonna override that storage. So in this case, that address, pool info, this ERC 721 that we deployed, if the pool A calls the hook and initialize it, then the pool B can also initialize it again, and that would break things. How to fix it? Very easily. We have to do proper pool management, maybe use a mapping so that we can track every single pool in a different storage slot. Access control, second one. In this example, also implementing the before initialize function, we're basically doing exactly the same as before, deploying the ERC 721. As you see, this function and all the functions defined in a hook are all public, and therefore, external. And since they're external, anyone can call them. And that means that if I wanted to just call the before initialize function again for a specific pool, since all the information that I'm showing there in the parameters, I just can set them when I send the call data to the blockchain. I can, without any restrictions, for example, override a specific storage slot of a specific pool. How can we fix this? As we saw before here, the pool manager is the one that usually calls the hook. This is not necessarily always like that, and I think that the Uniswap team decided not to add any sort of like modifier in the hooks just to give full customization for developers. But most of the cases, you would want the pool manager to be the one that calls the hook and modifies its storage. So very easy way to fix this, just add a only pool manager modifier and avoid these hooks to be called from other contracts. Logic checks, this is more like not that related to Uniswap V4, but something that I'm pretty sure we're gonna see a lot in audits next year when we check hooks. And it's basically that since these hooks are gonna be developed by anyone, you're gonna have bugs. And these bugs can be like very silly things, such as in this contract, we see this before add liquidity hook that in the last line this is basically it mints some ERC20 tokens as a reward, let's say, for liquidity providers. And as we can see in this code, every time that a user adds some liquidity, will override its rewards. Easy way to fix this, just add a plus there. This is a very silly issue, of course, and I just want to reinforce that again. Like, logic issues is something that we're gonna see in hooks very often, and it's important to get this code base and hooks audited. Finally, unexpected reverts. This is a very interesting one, and it's also kind of like it can happen in Uniswap V4 because of the flexibility that it gives. Let's say that we have a before remove liquidity function here that in the last line checks that a specific price is greater or equal than a minimum price. And also, let's say that for some reason the price oracle is always higher than this specific price. What will happen is that this before remove liquidity function will always revert, which can be a problem because if we add liquidity and then we want to remove it, we are not going to be able to do it. So this sort of interactions in pairs, as in like add liquidity, remove liquidity, we always have to take into account and be aware that if we want to, for example, interact with the contract, with the pool, and for example, we add liquidity, we have to make sure that we can remove liquidity. This is, again, a very simple example that can get your liquidity locked, and you're not going to be able to collect fees because the collection happens in this operation. But there are other examples that can trigger this and other things. Some of them, arbitrary calls to external contracts. That's something that can definitely happen again, because if you want to do a swap and after or before swap implements an arbitrary call to an arbitrary address, someone could take all our tokens, for example. That's a very common issue in the past. Upgradability. All these hooks can be upgradable, so we have to be aware to interact only with those hooks that we know that if they're going to be upgradable, the process of upgradability is set placed properly, and that we're not going to see any, or we're not going to have any sort of surprises. DOS is via long loops or external calls that revert, very similar to the example that I gave before. But let's say that in that specific example, we perform an external call in the remove liquidity contract, and that function call reverts. Well, we're not going to be able to remove the liquidity. It could be that that contract is also upgradable, and then they upgraded it, and it also reverts because of that. So also be aware of that. Since we can basically build protocols in hooks, we have to be very careful that we don't write inefficient code that will make all these operations very expensive. We can have Oracle price manipulation, spot price issues, or outdated price issues in our oracles. So basically, any known issue in DeFi can be present in your hook. So as a general recommendation, when we build hooks, we have to be aware that things can go wrong not only because of how hooks are implemented and some of the examples that are inherent to Uniswap V4, but also the fact that builders are going to be building on top of V4 through hooks can introduce normal bugs that we see every day in DeFi. And that's it. Thank you so much.